Hi, everyone. My name is Changhoon Hahn. I'm a postdoc at Princeton University. I'm also the co-chair of the DESI Bright Galaxy Survey Working Group. And today I want to talk to you about the Probabilistic Value-Added Catalog for BGS. The Dark Energy Spectroscopic Instrument, or DESI, for those of you who aren't familiar, is a galaxy redshift survey on the Mayall 4 meter at Kitt Peak, which over the next 5 years will measure the spectra of over 30 million galaxies. And it'll do so using robotic fiber positioners that allow us to measure spectra of 5,000 galaxies simultaneously. The spectra will have optical wavelength coverage with R of 2,000 to 5,000. And the main goal of DESI is to probe fundamental physics by measuring the dark energy equation of state, the growth of cosmic structure. It'll provide tests of GR, measure neutrino mass, and more. And one of the things I want to convince you during this talk is that DESI will also be very exciting for galaxy evolution. So here are some of the galaxy samples that will be measured by DESI. It'll have 2.4 million quasars at at redshifts above 2, and then it'll have 17 million emission line galaxies. And at slightly lower redshifts, it'll have 4 million luminous red galaxies. And at the lowest redshift, it'll have the DESI Bright Galaxy Survey. So the BGS will cover 14,000 square degrees, which is almost a third of the sky. And here's a comparison of the footprint of BGS in blue, SDSS in orange, and gamma in red. And it'll also extend out to redshift of 0.4. More importantly, it'll measure the spectra of over 15 million galaxies down to R of 20. This is 2 magnitudes deeper than the SDSS main sample. And here's a comparison of the number density of the BGS galaxies versus SDSS in orange as a function of redshift. You can see it vastly expands the sample by almost an order of magnitude. More importantly, BGS galaxies will span over 5 orders of magnitude in stellar mass thanks to its magnitude limit. Here I've highlighted the stellar mass as a function of redshift. Orange is the BGS main sample, and blue is the BGS faint sample. The DESI BGS will also have multiple value-added galaxy catalogs derived from DESI photometry and spectra. The one I want to highlight in this talk is the Probabilistic Value-Added BGS, or ProbaBGS, which will measure the physical properties of galaxies using DESI photometry and spectra. Here's just an illustration of how we will jointly fit the photometry, which is in orange, and the spectra, which is in black, and derive posteriors on galaxy properties such as stellar mass and star formation rate. So the goal of ProbaBGS is to derive full Bayesian posteriors on properties such as stellar mass, star formation rate, metallicity, and dust attenuation for all 15 million BGS galaxies. ProbaBGS will use an SPS model to jointly fit the photometry and spectra. And here's the parameterization of our model. I've highlighted the first 4 parameters. So the first one is the stellar mass, and the next 3 are dust parameters. And then the last set of parameters are for our non-parametric star formation history and metallicity history. So for our star formation history, we will use non-negative matrix factorization bases derived from Rita Togero. Here's a plot of the 4 components of the 4 bases as a function of look-back time. And so the star formation history will be a linear combination of these 4 bases with an extra burst term added. Similarly, the metallicity history will be a linear combination of these 2 NMF bases. And at this point, you might be wondering, how are we going to derive 15 million posteriors using FSPS? After all, Joel, when he recently fit 60 million galaxies, it took 1.5 million CPU hours. So if you do the back of the envelope calculation for BGS, it'll take 400 million CPU hours. So the short answer is no, we won't be able to do this using FSPS. Instead, we're using the recently developed PCA neural network emulators for FSPS by Justin Alsing. And we've trained these neural networks using 5 million SEDs. And we're able to achieve percent level accuracy and 1,000-time speed up using these emulators. This is work I've been doing with one of my students, James Kwan, an undergrad at UC Berkeley. The entire ProbaBGS pipeline is publicly available on GitHub. Here are some of the extra features that come with it. One thing I'd like to advertise is that you can derive a posterior in 3 lines. So the 15 million posteriors from PAPA-BGS will definitely enable the standard population analyses, but now with the unprecedented statistics of BGS. So this will allow us to measure precise luminosity functions, stellar mass functions, star formation sequences, and all of these. And I've highlighted a number of different applications that I'm particularly interested in. But beyond that, because we have posteriors on the galaxy properties, this will allow us to use new statistical approaches. For instance, we can now use Bayesian hierarchical models for population inference, and we can derive probabilistic stellar mass functions, luminosity functions, star formation sequences. But more than that, since we have the posteriors, this will also enable proper inference, which I'll talk about for the rest of my talk. So as I'm sure many of you are familiar, Adam and Joel recently demonstrated that both parametric and non-parametric SPS models impose undesirable priors on derived galaxy properties such as star formation rate or metallicity. So here's a number of panels that show the prior on log-specific star formation imposed by parametric models in the top panels and 3 different non-parametric models in the bottom panels. The PROBA-BGS SPS model will also impose undesirable priors on the derived galaxy properties. So here's the 2D prior of specific star formation rate and mass-weighted metallicity. And you can definitely see that it's not a uniform distribution. However, Will and Marius recently showed that you can apply maximum entropy priors on the model parameters in order to impose specified priors on derived galaxy properties. So if you have the original prior on the model parameters theta, you can derive this maximum entropy prior by multiplying it by R of f of theta, which is the specified prior on the galaxy property. For instance, this could be a uniform distribution over the original prior that's imposed on the galaxy property. So let me go back to the undesirable priors on galaxy properties that were imposed from our SPS model. And now if we apply the maximum entropy priors to this, here's what the priors look like. As you can see now, they are uniform priors on specific star formation rate and metallicity. So with the posteriors from PROBA-BGS and the maximum entropy priors, we'll be able to derive unbiased galaxy properties for all 15 million BGS galaxies. And currently, we're in the process of demonstrating this using through the Galaxy Quasar Physics Mock Challenge, where we're using simulated spectra and photometry from semi-analytic models and cosmological hydrosims in order to demonstrate that our PROBA-BGS pipeline can recover the true properties. This figure here just highlights one of the preliminary results from that. It plots the bias in inferred stellar mass and the bias in star formation rate, and you can see that we're able to recover the true galaxy properties quite well. To summarize, the DESI BGS will measure spectra of over 15 million galaxies over the next 5 years, down to R of 20 and extend out to redshift of 0.4. PROBA-BGS will provide posteriors on the physical properties of these galaxies from jointly modeling the photometry and spectroscopy. Moreover, with the posteriors that PROBA-BGS will provide, this will allow us to do proper inference and derive unbiased galaxy properties using maximum entropy priors, and it'll also unlock a whole slew of new statistical approaches that we can use for galaxy evolution. I just want to briefly mention that DESI is currently completing its survey validation, and the main survey will begin in just a few months. And already, as part of the survey validation, we have over 170,000 spectra of BGS galaxies, and we'll be constructing a value PROBA-BGS with the SV data, and that'll be coming very soon. Thank you.